There's only one rule for each. What is it?
They stay the same.
They stay the same. So I can just write this down and almost have the answer to the question, as long as I put plus C. So guess what a lot of the tricks are going to be in the moment? Index laws, muck you up with ease, and all sorts of other stuff. Then you got to divide by, and I feel like writing it in red. I feel like it. Do I do it? There's the answer. What have we done? To undo the fact that we times by 2, now we've got to divide by 2. To undo the fact that we multiply by the derivative of the power, to make up for it, we've got to divide by. Now, think about maths teaching. You guys have just got the hang of differentiating, and now we do it in reverse. That marks people's brains up. So what am I left with? Oh, by the way, where'd that 2 come from? I put the little arrow all the time. It's actually what I call again, what do I call it? The derivative of the inside. What inside? The inside of the power, the index. It's really that power has a bracket around it. Right? So we're always going to have that bit. So the answer is too easy, just then it's a 2. So could you just see that in your head? A whole lot of you will soon. And you'll just go, divide by 2, it's 2e to the 2x.
So it'd be anti-different?
Yes. So integral is an anti-diff, in other words, just reverse the process. Number 2 has a good old faithful rearrange first. In other words, use your index laws. How do we rearrange? We're going to use index laws. And I've got to move the denominator to the numerator. We're not integrating at that stage, all we're doing is rearranging it. So then I'd have a 6e to the minus 3x. So if I move it from a 3x, a positive 3x, and I move it to the numerator, that becomes a. And the interesting part is you'll know that rule, but you'll get into this and you mess it up. Now we can do the question. Write the same thing, plus c. We've forgotten one thing. What is it? 3 to the inside. So I could divide by minus 3. So there it is there. So if you do this forwards, which we could do in a moment, so now we've got an answer of minus 2e to minus 3x plus c. Now everyone says, is that acceptable? Well, I'd hope it was, but I suppose there'd be times when it's not. So what are the people going to do with it? 2 stays on the top. 2 stays on the top. So it's a minus with a 2 on the top and an e to 3x on the bottom. Did the 2 move? No, because it's not affected by the minus 3x. Only the e is affected by the minus 3x. That's why I say the minus 3x is sitting on the e. So, this one. Do we have to rearrange? Yes. And what's one of the most common things when we rearrange? Index laws. So what have I got? The integral of 10 e to the x to the half. And a lot of people, that mucks their brains up. You remember what to do, Elijah? If we had x squared to the 4th power, what do you do with the 2 on the 4th? You times it. So what are we going to do with those powers? Times it. What does that get us? So still haven't done the integral. We're still rearranging 10 e to the half x. Oh my goodness, that mucks people's brains up. Especially if it's in the middle of another harder question. So really I can just put a half there. How many people will think that? You will after a while, maybe. Depends how often you do it. Now we're ready. Write the same thing. Plus c. And what are we dividing by this time? I'm going to stop going red pen because I think the black turns out better. And the big question, 10 over a half. 20. Who just doesn't hesitate? Some probably do. How many halves in 10? If you had 10 pizzas, you cut them in half. You got 20 halves.
Well,
if you had $10 divided by 50-cent coins, how many 50-cent coins in? You know how many people write 5? 10 people write 5. Because they think they're halving 10. It's not halving 10, it's 10 divided by half. That's maybe for a moment some of you need to see this as well. How do you do a divide with normal everyday fractions? You write a multiply.
When you flip.
Yeah. We call it normally invert and multiply. Yeah. So therefore it turns out to be 20. What's the trap? So it's actually a 20 e to the half x plus c, and I'm running out of space. Is that good enough?
You could do.
You put the square root back in, can't you? Or could you? Do you want to? I don't. I can imagine, yeah. I can imagine people sitting there going, oh, you got to write 20 square root of e to the x. And you go, oh, no, I don't. Now we get a bit tricky, and this is where the video gets too long. Well, nah, this one's easy. Is this able to be done straight away with no thinking? Is it in the correct form?
Sorry.
Is that in the correct form for us just to write the answer down? Absolutely. So I'll just write what's there. So why did I put that one in? Divide by how much? 5. So the derivative of the inside is really, there's a bracket there. What? I want you right, mate. So what have we really got?
3.
So could you have done that one without showing any working out? 5 into 15 goes 3. If it makes sense to your brain. 5 into 15. Some you could look at these. 2x into 6x. Oh my goodness. As it works to your brain. 2x, which is a derivative of that, into 6x is 3. And you can go like that and write the answer down. But if you can't see that, what are we going to do? You write the same thing down, plus c. What are we going to divide by? Derivative, start for me.
2x.
2x. Of course, you guys won't have to say the derivative inside, you just think it. 2x. Now, the x will cancel. So by the way, if that was a 3 there, when I differentiate it, I'd get 3x squared, and the x's would not cancel. So therefore you need a new method. And by the way, what you did recently, you could use the trapezoidal rule, the midpoint rule, the over and underestimate rule. You could use Simpson's rule and get that integral if it said from 1 to 3 or 2 to 5, whatever it said. Yeah?
Is that exam stuff?
Sorry?
Would that be an exam stuff?
Nah. That's just one. It's really an appreciation of more about immigration. That's all it is. So now the x's cancel. The 2 into 6 goes 3. X squared minus 10 plus c. And on 6, I went the whole hog.
What? Oh.
It's actually the same as 5. If you have a look for a second, I made that a squared and I made that a cubed. Because when I differentiate the cubed, I get a squared. And hopefully I can divide that by a squared.
3 plus 3.
Can you see it in your head?
I think.
So let's do it properly. Here's me doing the whole thing. 9x squared plus 12 plus c divided by something. Go for a one. What are we going to divide by?
It's just 3x squared plus 4.
Yeah. Plus 4. Watch out, you don't write 4x. So that one derivative becomes that. That one derivative becomes that. Now you go figure out what to cancel. And how many times have I said the most common thing that people mucked up with factorising is called common factors. So do you guys see there's a 3 there and a 3 there? When I write a test, seriously, hear my secrets. If I want to muck students up and just cause them to go wrong, if I make these multiples of 3, it's amazing how many students muck up. There's something about it. I've just done it year in, year out. If I made that, say, 8 and 12, no one mucks up. If I make it 5 and 10, or 5 and 15, no one mucks up. If I make it 3s, so 3 goes into both of those. We've got 3x squared plus 4 e to the x cubed plus 4x. 3x squared plus 4. And by the way, just to be fussy for a moment, the whole bottom section has a bracket around it. Why am I allowed to cancel the whole bracket? Because we're doing multiplication. It has an add, it's got an addition in the middle of it. But remember, x just represents a number, any number. If x turned out to be 10, we just go 304 over 304. Yeah, you've seen that before. So just pencil all them out. There's the answer to the question. We're done. I'll go over here. So we've got 3e to the x cubed plus 4x plus c. Question is, can any of you do that in your head? Whenever you notice now that this is 3 times bigger than the derivative of that, I don't know. Would I have done that when I was at school? If I did it often enough, I would. The trouble is you might not do one of these now for quite a while, other than today and a bit of revision. Done? You okay?